environments for learning is a simulation. Again, this is work that we're doing with middle school children. We have them working with a series of simulations to learn about ecosystems. And again, we look at the collaboration here because it gives students something very rich to talk about. And I'm just going to show a picture of River City. I don't know a whole lot about it, but it's an online environment where students can work in teams and take on the identity of scientists. So to the extent that students can take more ownership, I think that's one of the notions in these multi-user virtual environments. It's also really interesting that the lines between different environments get blurred. So I just showed you one piece of Stellar. But if you look here, you've got a virtual space for a context. You've got student workspaces. You've got the chat window. So you've got a lot of these features integrated in there. Okay. So I talked a little bit about collaboration spaces. When Sharon Derry and I first started doing our work in Stellar, we tried to have students do problem-based learning all online in an asynchronous discussion. And one of the things we learned is that students couldn't make decisions about really small things quickly. We would find out if they were trying to decide who was going to research what topic, it would take 2 weeks, where it takes 5 minutes in the classrooms. So we realized that different spaces afford different kind of activity. So one example is synchronous chat. I'm going to show you Jerry Stahl's virtual math teams environment. And then there's quite a number of different asynchronous discussions. But asynchronous discussions don't necessarily mean it's all online. You may have discussions happening in class. And that's certainly what we ended up doing because things we could accomplish really quickly in a short discussion just took too long asynchronously. So let me show you some examples. This is the Vmt Chat. And what's nice about this, so the chat window on the far end is just a regular chat. But what's really nice here is they've got a whiteboard and they've got a referencing tool. Because one of the things that you lose in online environments is being able to point to things and then be able to talk about what you're pointing to. So they dealt with that problem by using this referencing tool. What we did, so as we iterate, so this is from Stellar, it's the group whiteboard, and we call this an anchored discussion space. When we first started doing this, we had a whiteboard and then we had a threaded discussion, and students would post things in the whiteboard, and we'd try to get them to discuss it in the threaded discussion, and they mostly ignored us. This actually worked out to be a very nice design, and there can be many of these anchored collaborations, but here a student posts a proposal to incorporate ideas into an activity, and then Sally and Maria and Carrie all are able to post comments. So everybody's got a comment space for each proposal. So that solved problems of making sure that what people were talking about was situated near their discussion. And then it's Knowledge Forum, which is an asynchronous tool, but it's a large database and is being used in a lot of classrooms around here, but provides opportunities for users to connect ideas, build on each other's ideas, and it's very much tied to a theory of knowledge building and collective improvement of ideas. So another role for technology is helping to, and scaffolding is to structure information. And we can do it in a couple of different ways. One is by embedding expertise. So the RepTools hypermedia that comes out of my project was organized based on the structure of expert knowledge. Or it can be organized around theoretical models. So the Stellar hypermedia was organized according to cognitive flexibility theory, and I'll show you that in a minute. So this one is nice and simple. We really have kids moving from this how, what, and why questions because these are some of the deep principles that we know that experts think about. This one is clearly much more complicated. This is a page from the Knowledge Web, which is part of the Stellar system. It was designed according to cognitive flexibility theory, such that it links videos to multiple concepts to multiple video, and enables the conceptual crisscrossing of the landscape. So students will view concepts from multiple cases from multiple concepts. And you can also see that the students can see where they are in the space here and what other video clips might be related to that particular concept. Okay, so we've talked about structuring information, but there's also scaffolds that can make disciplinary thinking explicit. In the Beguile system, the Galapagos finches, they used scaffolds to help learners construct domain-specific behaviors. So these kids were studying microevolution, and the kinds of prompts that they had were to enable the kinds of questions that somebody in that domain would ask. Similarly, in the stellar work, we tried to promote a backward design model in which you think about what are the big ideas you want people to learn, what would be evidence that they've learned them, and only then about activities, as opposed to starting with activities and figuring what you get out of them. So here we've got that embedded both in the individual, we have those as the prompts in the individual notebook, and we have them as prompts in the group whiteboard, so you can see instructional objectives, evidence of understanding, and activities. So the students see that all the time. So then we get again to scaffolds that embed expert guidance. So we've still got the facilitators that are part of this distributed system. There are some systems that provide hints. So WISE is the web-based inquiry science environment, and here students are working on a problem about deformed frogs. And one of the things that you can see is this panda bear who's giving them a hint about a question that hints at something that they need to look at. So what are the black dots shown on the pictures? Why are they important? So another probably really important thing are scaffolds that structure complex tasks. So they help reduce the cognitive load and makes the task manageable. So that's some of that, making sure learners can actually do the task as well as learn from it.